Okay everyone, welcome back. We're going to have a little break from specialist content and do some maths methods videos. We're going to start with the 2024 Paper 1 multiple choice. Just feels like the most logical place to start with doing the methods papers. And I feel like if we're going to do one, we may as well do 2024. Our very first question is going to be a basic integral. Remember, all of your multiple choice questions should be simple, familiar. So, realistically, we should be looking at getting each question done in about a minute and a half. I think we had a little bit more time for the methods paper versus the specialist paper. The last time I checked it was a minute 40, minute 50. I might update that when I do the short response paper. I'll calculate the marks and figure out the exact time. I think it's about a minute 40, a minute 50 from memory for the methods paper. So, we really want to be trying to solve the questions. Like I said, if we can do it in a minute and a half each question, we save ourselves a little bit of time to spend on the harder sections of the paper later on. So, if we start with our integral question, this one is very point and shoot. We're integrating x to the power of 4. I imagine everyone was really happy when they saw a question like this. This should be something we've practiced a bunch. When I'm integrating, I raise the power by 1, divide by the new power. I get, well, 4 plus 1 becomes 5. So I divide by 5 or multiply by 1/5. It's the same thing. Raise my power by 1, and I remember to add the plus c. But even if I forgot that, all my options had plus c anyway. So we definitely should have been able to finish question 1 within that time frame. If we come down to question 2, we have a really nice derivative question. So the first two questions are really nice settling in questions for the exam. I'm differentiating y equals e to the power of sine x. Again, something we should have practiced a bunch before doing the external exam. To differentiate any exponential function, I differentiate my function up here. So if I differentiate sine x, I simply just get positive cosine x, and then I get e to the power of sine x. Again, this sort of part of my function is going to stay exactly the same. We simply just differentiate the function, like the power basically, for my exponent, or for Euler's number in this case. If we look at our options, again, that is going to be a, and we are getting through it very, very quickly. We are right on time here. If we go across to question 3, we're going to turn the page, go to question 3. I'm given this question here, which is an interpretation question around some kind of statistics problem. I'm given a sample size of n, so we're not told the sample size, to obtain a sample proportion p hat. An approximate margin of error for the population proportion can be obtained using the formula. Okay, so this is just the standard error formula that we have as part of our confidence interval. That's the bit where you do your sample mean plus or minus the error part e, which is the your z score, multiplied by the square root of p hat, 1 minus p hat, or divided by m. So if the level of confidence is increased from 95% all the way to 99%, then I'm just interpreting what's going to happen. Well, I know if I go from 95 to 99%, my Z score for a 95% confidence interval is 1.96. Off the top of my head, the 99% one, I'm trying to remember, it's 2 point something. I know it's going to be larger. I think it's about 2.5, right? It's going to be larger than the 1.96. So my Z score is going to increase. We can immediately eliminate A, where it says it's going to decrease. We can also eliminate C, where it says it's going to decrease. So now I just have to consider, would the margin for error increase if my confidence interval percentage increased? And yes, it's going to, right? Z, if my number for Z is bigger, I'm multiplying by Z, it's going to naturally get quite a lot bigger. So it's going to be B for question 3. It also makes sense, right? If I increase the confidence percentage, I'm trying to increase the accuracy that the population mean is contained within the confidence intervals. So if I increase my percentage, I have to widen the bands to make sure I have a better chance, basically, of capturing my population mean. If we come down to question 4, the first 3 questions have been really nice. Question 4, I want to simplify y equals 2 multiplied by the natural log of e to the power of x. No calculus required, just a simple simplification question. We can do this a number of ways. It depends how confident you are with log laws. Basically, I can do it 2 ways, right? I can bring this little x out to the front. I get 2. I don't know why I'm in pink, but let's just stick to pink. I get 2. My little exponent here comes all the way out the front, right? So we get 2x multiplied by the natural log of e. I should know that ln, the natural log, is the natural log to the base of e, which means this whole part here is simply going to be equal to 1. I'm left with, I'll go back to blue, I'm left with 2x multiplied by 1, basically, so my answer is simply just going to be 2x, and I get A for question 4. Coming down to question 5, in question 5, I want to determine the integral from a to b of 2 cosine x dx where a equals pi on 3 and b equals pi on 2. I'm simply going to substitute in my boundaries. I get pi on 3 here, and I get pi on 2 here. I've got 2 multiplied by cosine x. Now, the 2 in front of my cosine x is not something I'm going to be integrating. It is essentially a constant, so I can take it out as a common factor. I'll write this number in pink. I can put it at the front of my integral sign. So really all I'm having to do is integrate cosine x dx between those two boundaries. Okay, I can bring that 2 out the front. Just increase my chances of getting the right answer by a little bit. If you don't put the 2 out the front, this question should be pretty straightforward either way. I'll zoom out a little bit so we can see the whole thing. If I integrate, I wind up with 2 outside of, if I integrate cosine, I get positive sine, so positive sine x. And again, my boundary conditions are from pi on 3 to pi on 2. If I now substitute in my boundary conditions, I get 2 outside of sine of pi on 2 minus sine of pi on 3. And now really I'm using my knowledge about exact values. I'll just make it another curved bracket because I put a curved bracket out the front. I'm using my knowledge of exact values. What is happening? Wait, I've got something weird with my iPad screen right here. Let me remove that. And let me fix this. Getting it back into the center here. Okay. Lovely. Problem solved, sort of, seemingly problem solved. So now I'm going to use my exact values. I'm going to grab all of this and make it slightly smaller. If I grab all of this and make it slightly smaller, I should have enough room to write my final answer. And my final answer is simply going to be 2 outside of sine of pi on 2. If we remember, our exact values is going to equal 1. This is tech-free, so we have to know our values. Minus sine of pi on 3. Well, pi on 3 is the same as 60 degrees. Sine of 60 is going to be root 3 over 2. If I multiply everything by 2, we should be able to see that my answer is going to be 2 times 1, which gives 2. And 2 times negative root 3 on 2, which is going to give negative root 3. So my answer for question 5 is going to be C. Honestly, the first 5 questions, really nice in my opinion. I think you would be very happy if you did the 2024 methods paper. So far, at least, the multiple choice has been very nice. Question 6 is going to be product rule. So I'm going to let u equal the natural log of x, and I'm going to let v equal cosine x. Once I have each of these parts, I differentiate u, I differentiate v, I get u dash equals 1 over x, I get v dash equals, well, cosine, if I differentiate cosine, it goes to negative sine x. Now I can do my little cross. I'm going to multiply these two parts together, and I wind up with, I can write it 2 ways. I can write 1 on x outside of cosine x, but if you look at my options here in my multiple choice, notice all of my options have put it over x. We're going to copy that to make it a little bit easier to see our answer, and I get y dash is equal to cosine x all over x. And now normally we add, but because I have this negative in front of my sign, I'm going to subtract. I'm going to subtract sine x multiplied by the natural log of x. Your order here is not super important. If we look at my multiple choice options, you can see all of them put the natural log part first. I'm just going to grab this so we can see which one is our answer a little bit easier. But again, the order, not super important. They both mean the exact same thing. And we can see, just looking at my question, my answer is going to be D. For question 6, it is cosine x over x minus the natural log of sine x. Okay, let's go down to question 7. Again, the first 6 haven't been too bad. If you look at question 7, we are told that, I'm going to zoom in a little bit here so we can just see the question nice and clear. And I put my face over it, so as we zoom out slightly again. I'm told that 20 families are selected to participate in a lifestyle study related to family size. Okay, so they've all got the exact same frequency. There is 4 families with 1 child, 4 families with 2, 4 with 3, 4 with 4, 4 with 5. A random sample of 5 families is chosen from this group without replacement. A possible mean number of children in the sample is, and we're given 4 options. Okay, so there's no real way to calculate the mean here. I have no idea what the 5 families are in the sample. It's basically saying which of these options could be true. We can immediately rule out 0. Okay, there's no way to select 5 families and get a mean of 0. Even if I have 1 child 5 times, that is going to be well, 5 divided by 5, which gives 1, right? So I can't get 0, I can eliminate 0, and even when I think of that same logic here, if I consider getting 1, a mean of 1, that means I would have to have 1 plus 1 plus 1 plus 1 plus 1. In other words, I've got 1, 2, 3, 4, 5 families have to have one child. I have to select basically all of them, right? So I have to pick 5 groups of 1. I literally can't pick 5 groups of 1 because the maximum number is 4. I've got 4 groups of 1. So part C is literally impossible. I cannot get a mean of 1. 2, I mean, 2 obviously can be possible, right? You could have some combination. You could have, 2 1s. I guess what you have 3 1s, 1, 2, and a 3, something like that. I can try and do the maths off the top of my head. It'd be pretty easy to get a sample of 2 if I really thought about it, but we don't have to prove it's 2. Like, 2 just makes sense if you think about it. The same logic for 0, the same logic for 1, I guess I should say, right, for part C, is the same logic I can apply to part A, where the mean is exactly 5. Again, that means I pick 5 groups of 5. I have to pick 5 plus 5 plus 5 plus 5 plus 5, get 25 divided by 5, get an answer of 5. I'm not sure if I'm explaining this perfectly. Essentially, I can't get, if I choose 5 families, I can't choose 5 families with a sample size of 5, because I have a maximum of 4 families with a sample size of 5. So A is also impossible. B is the only choice that isn't impossible, basically, is how this question works. So my answer is going to be B. And this one, I will say, is a little bit trickier because we're not really solving anything. We basically have to look at what I have, realize the frequency of 4 thing matters. There's no way to get 5 groups of 1. There's no way to get 5 groups of 5. There's no way to get a mean of 0. So I'm basically eliminating all my options except for B is the only choice that it could be. Right? It's not definitely going to be 2, but it could be 2. It can't be any of the others. Okay, question 8. I have a graph here of f of x, and I want to identify my graph of my second derivative. If I want to identify a graph of my second derivative, admittedly, this question isn't too challenging to do in your head. You could kind of think it through, right? I should know for my second derivative test, I get an inflection point. My inflection point is equal to 0, basically, is how it works. So where it's going to cut my gradient will be at the inflection point. We can look at the graph and see my inflection point is going to be about here at 1, and I can look at my options here to figure out where it passes my x-axis at 1, meaning I have 2 options of C or D. The question is it going to be sort of like, I got 2 different lines, where is it positive, where is it negative? Okay, to determine that part, we might be it might be beneficial to basically draw a rough sketch of what the first derivative looks like. That might help us out a little bit, okay? So if I draw a rough sketch of what the first derivative looks like, I know that for my first derivative, I'm going to have a 0 point here, a 0 point here. It is going to be positive, it is going to be negative, and it is going to be positive here in terms of what my gradient is going to look like. I'll make it a little bit neat, right? You don't have to make it neat in the exam. A rough sketch is fine, but I'll get my axes nice and neat. So if I take that information into consideration, I know I'm going to wind up with zeros between 1 and 2. It's going to be positive before it hits my 0 point, so it's going to be coming down. It's going to look something like this. It's going to look something like this, where I get a 0 point here, a 0 point here, and this point here is going to be exactly at 1. That is where my inflection point is. That's where this little orange cross is here. Okay, so if we look at that, we look at all my information, we can see now the gradient is negative, 0, and it is positive. I also know if I differentiate a quadratic, I get a straight line. So it makes sense that I have these straight line options for part C and part D, okay? Because it's the second derivative we're testing. So, and actually, really, A, I guess, is the sketch of this. So, if I've got my sketch of my first derivative, I can see my gradient is negative, hits 0, then becomes positive. So, my option, or the correct answer, I should say, has to be C. C is going to be my answer, where it is negative, hits 0, and then becomes positive. D is obviously the opposite version of that. My answer is going to be C. In question 9, I'm given at a certain location, the temperature C can be modeled by the function T equals 5 sine pi over 12 x plus 23, where x is the number of hours after sunrise. Determine the rate of change of temperature degrees per hour when x equals 4. And I will say, this video has actually been very smooth. Like the multiple choice questions, I've done a lot of specialist papers that make you think a little bit more, right? You can kind of see why Specialist is considered harder than Methods in some ways. I would say so far the multiple choice questions for the Tech 3 paper, outside of question 7, which did make me think quite a lot, or required you to think quite a lot, these questions aren't too bad, right? I think having a goal of getting at least 9 out of 10, well, we'll see what the last two are like, but 9 out of 10 should be somewhat realistic. Maybe I shouldn't put that pressure on you guys, but I do feel like it's worth practicing the multiple choice and coming into the multiple choice with a decent amount of confidence. So if I'm trying to find the rate of change of temperature when x equals 4, I really want to start by differentiating my equation t with respect to x. So I want to find the rate of change. That word means I should differentiate. If I differentiate, I get, we'll go to blue, I get dt over dx is equal to, if I differentiate sine, I get just positive cosine. And when I differentiate a trig function, I multiply by the derivative of the part inside my brackets. Okay, the derivative of pi over 12, multiplied by x, is simply just going to be pi over 12. So I'm going to bring pi over 12 out the front. I wind up with 5 pi over 12. Oh, sorry, it's not sine, it's cosine. Cosine, the part inside the brackets is going to stay exactly the same, and my constant on the end, the plus 23, is going to disappear. So once I've done that, I can now substitute in my value of when x equals 4. If I let x equal 4, I'm going to wind up with 5 pi over 12 multiplied by cosine of, it's basically going to be 4 over 12. Hopefully I can see that 4 pi over 12, I should say. 4 pi over 12 is going to simplify it to give pi on 3. Okay, so I'm just going to put this here in case we didn't see what I mean here. If I put 4 in place of x, I get 4 pi over 12. I simplify the fraction and I get pi on 3. So now, again, I'm using my exact values. Quite a lot of exact values, I will say. So we have to be pretty sharp with those if we're doing the methods tech-free multiple choice. I should know that cosine of pi on 3, again, it's the same as 60 degrees. Cosine of pi on 3 equals a half. So I'm going to wind up with 5 pi on 12 multiplied by 1 over 2. If I multiply top line, multiply across my bottom line, well, 5 pi times 1 stays as 5 pi. 12 times 2 gives 24. So my answer is going to be B, 5 pi on 24. Okay, we'll come down to question 10. I'm just going to grab all of this, actually. I'm going to make it a little bit smaller so it kind of stays within the question a little bit. We're not sort of falling out onto question 10. If we come down here to question 10, I'm given that log to the base 10 of 6 equals 0.778. Remember, this is a tech-free paper. No calculator allowed. I want to determine the value of log to the base 10 of 600. So I'm told log to the base 10 of 6 equals 0.778. I basically have to think of a way I can break log to the base 10 of 600. I have to break this up into essentially two parts, where one of those parts is log to the base 10 of 6. So we're going to basically be unpacking or tearing apart our log laws to break up log to the base 10 of 6. The easiest way, or the most straightforward way, just looking at the problem, is breaking up into two numbers that multiply to give 600, where one of those numbers is going to be 6. So what I mean by that is if I split this into log to the base 10 of 100 plus log to the base 10 of 6, you can see if I use my log laws, 100 times 6 gives 600, and I've got log to the base 6 here, which I know the answer to, and more importantly, I have log to the base 10 of 100, which I know the answer to without needing a calculator. Depending on how you solve this, your teachers could show you different ways. Just to make it really clear, I think this is the easiest way to see it if we're not sure, right? I could just think 10 to the power of what gives an answer of 100? Well, 10 to the power of 2, 10 squared, gives an answer of 100. So I'm going to write my answer as being 2, plus I know log to the base 10 of 6 equals 0.778, and I'm going to get an answer of 2.778, which gives me an answer of C for question 10. If you struggle to see your logs, you might also do the way where, for just to show a different way to solve this, I get log to the base 10 of 10 to the power of 2. That equals 2 outside of log to the base 10 of 10. Whenever these two parts match, like earlier on in the multiple choice section, whenever these two parts match, my answer is 1. That also kind of shows that I get a final answer of, I'll move my face out of the way, of 2. So both ways get you to 2. This is how we can solve question 10. I will say, the multiple choice, I've got a squiggly line here. I'm just going to get rid of that so I have a squiggly line here. I will say the multiple choice, it's not, it actually, honestly, this wasn't too bad, right? This is in 2024. So whilst there's going to be some slight tweaks, I was actually pretty happy with the type of questions we got. We had some where we had to think, quite a lot of calculus, which is great. The stats questions, I think, were very good questions to ask when you can't use a calculator, really testing your theory knowledge. But with really good fundamentals, I do think this section is relatively achievable. Hopefully, you guys found this video helpful. If you have any questions or you want me to do anything specific within any of the papers, feel free to comment that down below. If you want to see papers from other states like New South Wales, VCE, WACE, feel free to comment that down below as well, and I can try to produce some videos for that. Otherwise, if you know people that do methods, feel free to share this video. That way everyone can benefit and help, right? High tide raises all ships, as they say, and I will see you guys in the next video. Goodbye, everyone. Thank you.